In this video, we are going to solve some numerical questions from chapter 3, vectors. Let's read the question. In the first question, they ask you to find the horizontal and the vertical components of a velocity vector as given in the figure. Please see the picture. Here we have the x-axis, we have the y-axis. And the velocity vector magnitude is given here as 20 meter per second. So as we already studied in the theory, you can get the component from the magnitude. So here the magnitude of the velocity vector is 20 meter per second. So I can just write that magnitude of the velocity. What's the magnitude? 20 meter per second. Now for finding the x component, here the x component is nothing but your horizontal component. Y component is nothing but a vertical component. That means v of x here is the horizontal, v of y is the vertical component. As we already studied the formula for finding the component for the x-axis, we have to use v of x, which is equal to the magnitude of the velocity vector multiplied by cosine theta. Now we already have the value for the magnitude of the velocity vector. The angle given here as 30 degree, I'm going to substitute the value here. So if you substitute the value in this formula, you will get 20 cosine of 30 degree. If you work out with your calculator, 20 multiplied by cosine of 30 degree gives you 17.32. So 17.32 meter per second. This is the answer for the horizontal component. For vertical component, v of y, which is equal to the magnitude of the velocity vector multiplied by sine theta. Now I'm going to substitute the value here. The magnitude of the velocity vector is 20 sine of 30 degree. So 20 multiplied by sine of 30 degree gives you exactly 10. So the answer for the vertical component is 10 meter per second square. So v of x value is 17.32 meter per second, and the v of y, the vertical component value, is 10 meter per second square. So this is the answer for the first question. Now we have the another type of question, and here also the question have the graphical representation. Let's read the question. What is given in the question? An airplane flies 300 kilometers due east from city A to B. That means, see the picture here, from A to B the flight is traveling 300 kilometers, and then 200 kilometers in northward from city B to C. So from city A to B, it covers the distance of 300 kilometers. From city B to C, the flight is moving towards the north direction, and it has the value of 200 kilometers. Now what we are going to do, we are going to find what is the magnitude of the displacement. So we are going to find the magnitude of the displacement. As we already studied, you can calculate the magnitude with the help of the component. So what is the component here? So here the 300 kilometer is the x component. Am I right? That means the displacement x component, and here this 200 is the displacement of y component. So our x component value is 300, our y component value is 200 kilometer. Clear? So with the help of the component, we can easily calculate the magnitude. So the formula for the magnitude is magnitude formula, which is equal to square root of the horizontal component square plus the vertical component square. So here we have the horizontal component square as 300 square plus the vertical component value is 200 square. So I'm going to calculate the value 300 square plus 200 square gives 360.56. So what's the magnitude? 360.56 kilometer. Understand? So this is the answer for the first part. And what's the answer for the second one? We are going to calculate what is the direction. As we already studied the formula for finding the direction, theta, which is equal to the tan inverse of the y component divided by the x component. I'm going to substitute the value here. So tan inverse of our y component here is 200. So 200 divided by our x component is 300. So what's the answer? Tan inverse of 200 divided by 300, we got 33.69. What's the angle? Theta, which is equal to 33.69 degree. So this is the answer for the second part. Understand? The third question, it tells you about the projectile motion, and in projectile motion we studied a lot of formulas, and in these questions we have 4 subdivisions. So we are going to answer one by one. What is given in the question? A cannon fired a shell with the initial velocity of 40 meters per second at an angle of 60 degree. So what's the initial velocity? The initial velocity here is 40 meter per second, and what's the angle? The angle is 60 degree. And here we have to ignore the air resistance, and acceleration here is nothing but the free fall acceleration. Actually, this projectile is an example for the two-dimensional motion, and here the angle is related with the horizontal axis. So now I'm going to read one by one question, and then we are going to answer one by one. So what is given in the first question? What is the time taken by the shell to reach the maximum height? So you have to see the picture, brother, here. When you just fire this cannon, the shell will come here and it will exactly like a parabola. Am I right? So when the shell reach the maximum height, what is the time? How much time this shell will take? So that means from here to here, what's the time? You are going to calculate the time value. So we already studied the formula. The formula for finding the time is time t, which is equal to V naught sine theta divided by the acceleration due to gravity. This is the formula. Actually, we studied everything very clearly in the theory. So for solving the numerical questions, I'm going to take only the formula. So what's the formula? So if the ball to reach the maximum height, how much time is needed? Actually here for the projectile, it has the time of flight two times of that time. So that means from here to here, it's a time. From here to here is another time. So the total time of flight t, which is equal to 2 times of time. Am I right? So if you find the value of the t, then for the total time of flight you can easily calculate. But in the first question, they ask you to calculate only the small t. That means from this point to this point. That means for the maximum height, what's the time? So I am going to write the formula as t, which is equal to V naught sine theta over g, and we have all the values. The V naught is 40 meter per second, and the angle is 60 degree, divided by the value of the acceleration due to gravity is exactly 9.8. So what will be your answer? 40 sine of 60 degree divided by 9.8. Here the answer is 3.53 seconds. So what's the answer for the first question? T, which is equal to 3.53 seconds. So this is the time for this, okay, from this point to this point. If you want to find the time for the entire, you have to use this. So by that, multiply these two, you will get the total time for the total time of flight. Now we have to find for the second questions. So we have to find the answer for the second questions. What is given in the second question? What's the total time of flight for the cell? So I already mentioned here, what is the total time of flight? The total time of flight is t, which is equal to 2 times of small t. So we already find the value of the small t in the previous question. So better I write the formula t, which is equal to, that means caps t, which is equal to 2 times of small t. As we already find the value of the t, what's the value of the t? The t value is 3.53, which is exactly equal to 2 multiplied by 3.53 gives you 2 multiplied by 3.53 gives you 7.06. So the total time of flight is 7.06. That means from here to here, what's the total time? Exactly double the times of small t. This is the answer for the second question. Actually, this is the unit second. What's the answer for the third questions? Calculate the maximum height reached. So if you want to find the maximum height, that means from the ground to this. So we are going to find what should be the value of the height. So we already have the direct formula. Time, the height h is equal to v naught square sine square theta divided by 2 times of the gravity. That means acceleration due to gravity. This is the formula for finding the maximum height. And we already have the initial velocity as 40 square sine square of 60 degree divided by 2 times of 9.8. So what will be your answer? V naught 40 square, so sine square of 60 degree divided by 2 times of 9.8. So the answer is 61.22. The answer is 61.22. The unit is in meter. So this is the answer for the third question. Now we have the fourth part also. That means the fourth sub questions. Calculate the maximum horizontal distance traveled by the cell. That is nothing but our range. So what is this distance? So this distance is called as range. The range formula, range, which is equal to v naught square sine 2 theta divided by acceleration due to gravity. So I'm going to substitute the value in this formula. 40 square sine 2 multiplied by 60 degree divided by 9.8. So the answer is 40 square multiplied by sine 2 multiplied by 60 divided by 9.8. The answer is 141.39. The answer is 141.39. The answer. And the unit is meter. And the unit is meter because the range, horizontal distance, is measured in terms of meter. If you want to use another formula, that is also possible. Better we can cross check our answer. So we have another rule for calculating the range. So the range, another rule is v naught cosine theta multiplied by the total time of flight. So V naught is 40 cosine of 60 degree and multiply by the total time of flight. So better I can take the value from here, which is 7.06. The total time of flight is 7.06 second multiplied by 7.06. So I'm going to calculate 40 multiplied by cosine of 60 multiplied by 7.06. So what's the answer? It's exactly the same answer, 141.2 meter. So the two answers are exactly very closer to each other. Clear? So either you can use the first formula or you can use the second formula. It's up to you. The fourth question, you have to see the picture. A ball is launched from the ground with an initial velocity of 40 meter per second. So the initial velocity is given as V naught, 40 meter per second, and the angle of projection theta, which is equal to 60 degree, towards a cliff of height h. That means you have to see the small h. Here the caps h is the maximum height reached. The projectile is reaching the maximum height. But here they ask you to calculate only the small h. And here for calculating the small h, better we can take the equations for motion with constant acceleration. The second equation. What is our second equation, brother? Just please recall that delta y, which is equal to V naught t minus half gt square. Why I put minus here? Because in projectile motion, for the velocity of the y-axis, the acceleration is the negative value. So I put the value of negative. That's what the positive of half gt square. Here is negative of half gt square. Why? Because of the velocity in y-axis. Now here the v naught is related with the y-axis, so I have to apply the rule. So v naught of sine theta multiplied by t minus half g t square, and the left hand side is the delta y. Here the delta y is nothing but, here it is small h. So here for this delta y, I'm going to write as h. So h, which is equal to, I'm going to substitute the value. The initial velocity is 40 sine of 60 degree, and the time is given here. So the ball strikes the cliff after 5 seconds. So the time is already mentioned, so better I can substitute the value here. 5 minus half 9.8 multiplied by 5 squared. So I'm going to calculate 40 sine of 60 multiplied by 5 gives you 173.20. So h, which is equal to 173.20 minus this part I have to calculate 9.8 multiplied by 5 square divided by 2 gives you 122.5. So 122.5. So I have to subtract the value 173.20 minus 122.5 gives you 50.7. So what's the answer for this height? So h, small h, which is equal to 50.7, and the unit is meter. In the second part of the fourth question, you have to calculate what is the horizontal distance between the cliff and the firing point. So firing point is here, am I right? The firing point is here, and then the horizontal distance reached at the maximum height of the cliff is here. So that means we are going to find what should be the range here. Understand? So we already know the formula for the range. So delta x, which is exactly equal to here, the range for this, which is exactly equal to V naught cosine theta multiplied by This time, which time? We have to use 5 seconds here. So V0 is 40 meter per second. Cosine of 60 degree multiplied by 5 seconds. So 40 multiplied by cosine of 60 degree multiplied by 5 gives you 100. So what's the distance from the firing to this cliff height? The horizontal distance is exactly 100 meter. This is the answer. So fifth question, we are going to use the vector addition, subtraction, something we are going to do here. So we have to read the questions very carefully. So what is given in the question? What is the magnitude of R and the direction? So that means you are going to find the magnitude as well as the direction for the resultant vector. So what is the resultant vector? The resultant vector is given as R, which is equal to 2 multiplied by A vector minus B vector. So we have to find what is the value of R, and then we have to find the value of magnitude for this R, and we have to find the angle for this R. So first of all, better we calculate what is the final answer for the resultant vector. So what is the final answer for the resultant vector? R vector, which is equal to 2 multiplied by A vector. That means you are going to multiply the scalar with the vector. So I have to multiply these two in this entire equation for I cap as well as for the j cap. So 2 multiplied by 4i gives you 8i. 2 multiplied by 1 gives you plus 2j cap. So this is the value of 2a minus, what's the b vector? It's minus I cap plus 3j cap. Now we have to subtract. So 8 minus of minus 1. Actually here minus I cap is nothing but it's 1 I cap, minus 1 I cap. Am I right? So if you subtract, what you will get, brother? 8 minus of minus 1. So that means 8 plus 1, which is exactly equal to 9 I cap, 2 minus of 3j cap. That means you have, whenever you go for addition or subtractions, you have to add I cap with I, j cap with j cap. So here I have to subtract 8 I cap only with I cap. So for the second part, 2 j cap minus of 3 j cap. So its answer is minus j cap. This is the answer for our resultant vector. So we found the value of the resultant vector. Now we have to find the magnitude for this vector. So what's the magnitude for this vector? The magnitude for the resultant vector, which is equal to square root of the x component of the resultant vector square. So that means 9 square plus, and then square of the y component. That means minus of 1 square. So what's the answer? Its values is 81, and minus 1 square is plus 1, here plus 1. So square root of 82 is 9.06. What's the answer here? 9.06 is the answer for the first part. That means magnitude. And what's the answer for the second one? We have to find what is the angle. So theta, which is equal to tan inverse of the y component over x component. Here the y component is minus 1 and the x component is here 9. So what's the answer? Theta, which is equal to tan inverse of the y cap is minus 1 divided by 9, and you will get the direction. So tan inverse of y over x minus 1 over 9. So I got minus 6.34 degree. Minus 6.34 degree is the angle for this fifth question. Clear? Now we have to solve the sixth question. Again, we have two vectors. We are going to find the resultant vectors. So we have two parts. First, I am going to find what is a plus b, and then I am going to find r which is equal to a minus b. So or vector which is equal to A vector plus B vector. So first of all, I'm going to write A vector. Better, I can write A vector here. 2I cap plus 5j cap is the A vector. What is my B vector? Minus 2I cap plus 3j cap. Now we are going to find the resultant vector. What is the resultant vector? R, which is equal to A vector plus B vector. That means I'm going to add the A vector with B vector. So 2 plus of minus 2. What's the answer? It's 0. 0 I cap. Likewise, 5 plus 3 gives you 8 j cap. This is the answer for the first part. And what is the answer for the second part? We are going to find A minus B. Better I can write our A vector one more time. 2 I cap plus 5 j cap, and our B vector is minus 2 I cap plus 3 j cap. I'm going to find the resultant vector as A minus B. So I have to subtract the I with I and J with J. So 2 minus of minus 2. So what's the answer? It's 4 I cap. 5 minus of 3 gives you plus 2 j cap. This is the answer. Clear? So we have the first part and we have the second part here. Now in seventh question, we are going to fill in the blank. So we have 3 questions. So if you want to answer these questions, you should strong in the theory. So we have to read the questions one by one. A dash quantity is characterized by the magnitude, but it has no direction. So it's simply, we already studied, am I right? So it's the answer for the first question is scalar. The scalar quantity gives you only the magnitude. It has no direction. Is the answer. In the second question, a dash quantity is characterized by a magnitude and the directions. That means a vector will gives you both magnitude and the direction. So the answer for the second question is vector quantity. And in the third question, the horizontal component of the velocity of the 2D projectile always remains. So better I can draw the diagram. When you just see the diagram, you will get the idea. So projectile motion has the parabola trajectory. Am I right? So when any object is moving in this trajectory path, you have to see the x component of the position of the vector remains the same, but y component will vary. So what's the answer for the third question? Our x component, that means x component here is nothing but the horizontal component. So the horizontal component you have to see from the picture, there is no change in the horizontal component. So what's the answer? So you can just give the answer as same or a constant. Same or constant. This is the answer. Now we have to match the following. So here we have 4 questions and you have to read the column A and column B very carefully. So AY. So AY indicates the Y component and AX indicates the X component. So that means here AY is the Y component, means it indicates the vertical component. Am I right? So the answer for the first question is the vertical component. Likewise, the answer for the second question is horizontal component. And the third question, use the formula for finding the magnitude of the resultant vector. So the answer for the third question is here, magnitude of the resultant vector. And the question for the fourth question is A vector dot B vector. As we already studied the vector multiplication. So in dot product or scalar product, the answer is the scalar value. So that means this A dot B is called as scalar product or dot product. So it has another name. Am I right? The dot product or scalar product is indicated by A vector dot B vector. So the answer is here. That's it. So we solved 8 questions and please take practice. That will gives you more improvement for you. Okay, thank you so much. Please, if you like this video, kindly subscribe my channel, and if you have any doubts, please feel free to contact me through the comments, and please kindly share the link to your friends. By that, your friends will get benefited, they will get some information. Thank you so much.